Hello everyone, welcome back to Little Math 1 here online. Thanks for everyone who took that quiz. We are going to move on now that we've taken a quiz on that. We've spent a couple weeks going over all that. We're going to be moving on a little bit. Take some topics from Module 8 that you're going to want to know moving forward into next year. And then in a couple of weeks probably combine what you just quizzed on, the triangle congruencies, along with these next handful of topics, and give you at least one more quiz and then give you a test for those looking to raise those two category grades, okay? So today should be a pretty quick one. The first couple are going to be a review, but as we do them as a review, I want you to kind of notice some things as well so that when it becomes new, we can make a connection to the new types of problems. So the directions tell you to find the distance between each pair of points, round your answer to the nearest tenth if necessary. So we have actually already done these problems ourselves during the school year. What we would have done, I don't know, whenever we had done these earlier this semester, we would have turned this into a right triangle. So we would have drawn a little line segment here. So where it lines up at this point, we draw a line segment to here so that we ultimately end up with is a right triangle. And because it's a right triangle, we were able to use the Pythagorean theorem, the whole a squared plus b squared equals c squared idea. For this problem, I'm going to switch this around for these couple of problems so that it'll hopefully make some sense what we're going to be doing next. But the exact same thing. You still have your a squared plus b squared equaling your c squared. So if we look at this triangle, from this point, well, let's do the smallest side first. So from this point to this point, you would go from this point 1, 2, 3 steps. So our A is 3 squared, and then our B would be the segment length here. So if I start here, I would go 1, 2, 3, 4 steps. So we would do a 4 squared, and that would then equal our C squared. We would then solve this. So C squared is equal to 9 plus 16. When we add the 9 and the 16 together, you're going to get a 25. One of the things that we did talk about, in order to get rid of this squared term, the way we get rid of a squared term is through square roots. So we would take the square root of both sides, and we square root of 25 would get 5. So what that tells us is this length from here to here, this was our hypotenuse, this must be 5. So this was our B, that was our A, the hypotenuse is always our C. Should have mentioned that. Hopefully we remember that. And what we find is that this ended up being a 5. Okay. So what I want you, let's do one more, and then we'll kind of start pointing out what's happening with this. So in number 2, same exact thing, where we're trying to figure out what's the length from this point to this point. So we're going to make a right triangle. So if I put a dot right here, then I line up horizontally with this point, vertically with this point, and we end up with a nice 90-degree angle. Because it's a right triangle, we're looking for this length here. This is our C, because that's the side that's opposite of your right angle. That's the hypotenuse. So we're going to set up our Pythagorean theorem. A squared plus b squared equals c squared. We're just going to flip the sides around. Smallest side we're going to call A. So if this is A, we want to figure out what's our change from here to here. So 1, 2, 3, 4, 5, 6. So that's our A, 6 squared. And then our horizontal distance here, so 1, 2, 3, 4, 5, 6, 7, would be 7 squared. So think about where we're now getting these as we get to this. What we're finding here is our change in y, and our change in y would equal, we said, 6. Here, we're finding our change in x, and that would equal 7. And then when we do that with the Pythagorean theorem, that should give us the missing side, which is our C. Same process, solve this. 36 plus a 49. 36 and 49 would give us, what, 85. Take our square root of 85. If you go back to our directions, the direction said round to the nearest tenth. Okay, if we look here, if necessary, this one will be necessary. So this we would throw into our calculator. Square root of 85 should give us 9.2. Okay? But what I want you to understand, the way we're getting A is the change in X, and the way we're getting B, in this case, was our change in Y. Okay? So just keep that in mind. Number three, one more the old way, where we're going to turn this into a right triangle. Here's my 90-degree angle. Because it's the right triangle, we can use the Pythagorean theorem. C squared is equal to A squared plus B squared. So C squared, which is what we are looking for. We want to know C. What's our hypotenuse? All right, think about what A is. A is our smallest side. So A would be, if I start at this point, 1, 2, 3, 4. So again, what at A is, it's really the change in your Y values is 4. That's how long that side of the triangle would be. If I want B squared, then I would start here and I would take 1, 2, 3, 4, 5 steps. That's my B. And what this was our change in X. So the difference between this X and that X. Okay. So we go ahead and simplify this. 16 plus 25. That's our C squared. Add those together. You're going to get 41. We would then take the square root of both sides. And we should get 6 points. So what does that give us? 6.4. All right. So what I want you to understand for all of these problems is when we set up C squared is equal to A squared plus B squared, the way we're always getting our A squared and our B squared is we're basically figuring out what's the difference between this point and this point in terms. Why did I say that? This should be X's. Sorry, as I now look at this. This should be our change in X. So we're really figuring out what's our change in X, what's the difference between our X values, and then we're always figuring out what's our vertical change, our change in Y values. Then every single problem, we get to this step here where we've got to use our square root. We did it here, we did it here, and we did it here. So we always are going to have to take the square root. Well, instead of using numbers, we're going to already have changed our A and our B to this is the change in X, B was our change in Y. What if we took our square root right now? Because we always have to do that. And what our C is always going to equal, and remember your C is always your hypotenuse, is the square root. Now, we used A and B. Actually, let me do this in a little different order. A squared plus B squared. All right, so this should be our A. This should be our B, but we're just, every time we found our A and our B, it was basically our horizontal change was one of them, and our vertical change was the other. So our change in X over our change in Y, okay? This formula here, sort of, we're gonna make one little tweak to this. This is what we would call the distance formula. So when you look at this formula, this is what we are calling the distance formula. We're gonna make one little tweak. And what we can always do to figure out the length between two different points, which is basically our hypotenuse C, is using the distance formula, where we would have taken our change in X squared plus our change in Y squared. So the last thing I'm going to do with my X's here, the whole little delta X means it's the difference in my X values. So you're going to see it written as X sub 2 minus X sub 1. That's the change in X values. So if we go back to this problem, this had an X value of 1. So let me write that down here. This point had an X value of a negative 4. Notice how our change in X was 5, because all I would need to do is take the 1 and subtract the negative 4. That gives us the 5 that we just counted off and that we would have plugged in here in order to figure these out. If we would have done our change in Y, 1, 2, 3, 4, that's our change in Y. But what I really did is I took this Y value of 5 And then this y value of 1, if I went ahead and did 5 minus a 1, it's going to, 5 minus a 1, it's going to give me this 4. All right, so we also then write the change in y as just the difference in y. So this is the old way. If we know our graph, we can turn that into a right triangle, use the Pythagorean theorem. But if we then get to like 4, 5, and 6, we don't want to have to create a coordinate plane and then have to graph them and do the Pythagorean theorem. So what we can then do is use this guy. This, when we start talking about a distance formula, this is the distance formula. This is how we can find the distance between any 2 points on a coordinate plane. Okay, now it's really the hypotenuse, but typically you will see this written as d because it's just indicating that's our distance formula. But it's really derived from the Pythagorean theorem. So up here, and all we did is take the square root of both sides. If you go to number 4, if I now ask you what is the distance between this point and this point, we don't want to have to come up here, draw a coordinate plane, plot them, and do the Pythagorean theorem. What we're going to do is use the distance formula. So the distance formula is the difference in x's, so the change in x, so x2 minus x1, plus the difference in y's, so we're going to subtract our y values, and then each one of those gets squared, because really it is just the Pythagorean theorem, and each time we are squaring those values. All right, so now we go ahead and assign these values. This is point number 1. This is point number 2. So similar when we did the slope formula, this means we want the x coordinate in the second point. So we go to the second point, our x coordinate is 2. So I'm going to do 2 minus, this means go to your first point, find the x coordinate, and that would be 3. So I'd have 2 minus 3 squared. Plus, this means go to the second point, find your y coordinate, that's a 2, and then we're going to subtract. Go to the first point, and the y coordinate in the first point should be 0. If we then solve for the distance, the 2 minus the 3 gives you a negative 1 squared. Forgot my squared here. And then the 2 minus 0 squared should give me 2 squared. So what that's going to equal is the square root. So a negative 1 squared is just a positive 1. 2 squared is going to give you a 4. What that gives us is a root 5. That is not a nice perfect square, so that means we want to round this to the nearest decimal place. So you throw the square root of 5 into your calculator, and our final answer then would be 2.2. That is the distance between these 2 points. Okay, and it's just using this guy here, which is your distance formula. So number 5, same exact process. Here's our distance formula. So I'm just writing this out with variables. Consider this point number 1. We'll consider this point number 2. Here's an x, y. Here's x, y. And then we're just going to plug them into the appropriate spots. So this means go to the second point, find your x coordinate. That's going to be a negative 1. Then we're going to subtract, go to the first point, find your x coordinate. That's going to be the negative 2. And then that needs to get squared. This means go to the y coordinate in the second point. So that's this guy here, the 4. Subtract the y coordinate in the first term. That's going to be your negative 1. So what's really common with this, it happens with the slope formula often. You get these double negatives. So right here, when I have the minus a negative 1 minus a negative 2, minus a negative really tells us we have plus a positive. So what this should combine down to equal would be a positive 1 squared. Same thing happens here. 4, and then minus this negative 1, minus a negative should turn into plus a positive. So that is a positive 5. So what we should end up with is 1 plus 25 when we square these two things. Add those two together, and we get the square root of 26. That then, to the nearest 10th, is 5.1. All right, 6, and the final one. One more. So you'll just need to have this formula memorized. Actually, maybe you don't have to have it memorized because your quizzes and everything would be open notes, open book. whatever. So if you have this next to you, this is your distance formula, okay? So let's plug our stuff in. The x coordinate in the second point would be -1 minus the x coordinate in the first point would be the -6. And then we need to square whatever that is. Then we go to the y coordinate in the second point. That's the 1 minus the y coordinate in the first point. That's our 6. And then that needs to get squared. So in this first one, we end up with the double negative again. So the -1 plus 6 should give us a +5 squared. Plus, and then 1 minus 6 should give us a -5 squared. Square each of those. So we should have the square root of 5 squared is 25. A -5 squared is also 25. Add those, and what we're really looking for is the square root of 50. Let me throw that in real quick. That should give you 7.1. So the distance formula would have worked for numbers 1, 2, and 3 up here if we had chosen that. We hadn't talked about it, but this is kind of the old way. Still a very valid way, especially if it's a triangle, and we can just set up a little Pythagorean theorem that's really short, sweet, something you've now been doing for a couple of years. If we don't have a graph where we can create our triangle, we're just given 2 random points and asked to figure out how far apart they are, then we want to be using our distance formula. Okay, so the first 3 problems should be review. 4, 5, and 6, I think for a lot of you would be new, but if you've seen it before, then even better. It should be pretty straightforward, pretty simple if we just get that formula down. Okay, so if you have any questions, let me know, and have a good day.